In this clip we start a new topic, that of determinants, more precisely the determinant of a matrix, because determinants are associated with matrices. And we'll start with some notation. Here we're taking a determinant of a 2 by 2 matrix. Notice vertical bars. Now actually we start out with a matrix which we write with little corners here. That would be a matrix. And if I drop these corners and just keep the two vertical lines, then it's the determinant of that matrix, and it has a value which is a number. And the way we compute this number is you multiply this diagonal, and then you multiply this diagonal, and you subtract the first product minus the second product. So that we have 1 times 4 minus 2 times 3. And if you want the actual answer, though it's less important, then it's 4 minus 6, which is minus 2. So the determinant of this 2 by 2 matrix is minus 2. And by the way, we will only be talking about square matrices, so we're going to have n by n matrices, plural of matrix is matrices. We'll do some 2 by 2 and then 3 by 3, and we'll have a 4 by 4 one also in this clip. But square matrices. Now, this is not the only way of writing a determinant. It's the most common. You actually have the numbers in the bars. Sometimes we would just leave the matrix form and just write the word det, short for determinant, in front of it. And if the matrix has a name like matrix A, then we would write the determinant of A with the brackets, or without the brackets, just det A, just like here, determinant, and then the matrix. Anyway, these are minor variations. So that's our first example of a determinant. Now let's go on to a 3 by 3. And note that I'm just being technical here, how to compute determinants. I haven't discussed where it came from and what it's good for. At the moment, we're just learning how to compute them. Now, if you have a 3 by 3, remember we can't have funny shaped ones like a 3 by 5 matrix. We had a 2 by 2, and now we're doing a 3 by 3 and matrix, and finding its determinant. There's something called expanding along a row. You pick one of the rows. Let's say we take the first row. Now I'm going to take each element at a time, and each element will give me a term in the sum. The first element, I cross out also the column it's in, and then what I write is a product of 3 things. First of all, there's the sign, and that's a plus. I'll explain more about that in just a moment. It's plus or minus. Then I put the element, that's this 1 here, and then I put the 2 by 2 determinant of what's left after I've crossed out the row and column. This plus sign comes from, like a matrix but with signs, plus, minus, plus, so on, checkerboard style pattern. And the top left always begins with a plus, and then you alternate plus, minus, plus in each direction. So that's the plus. So our next element, which is going to be the 2, will have a minus. So this time we're taking the 2, so we've got the row and the column crossed out. And then the next term will be the sign, minus from here. Then the element 2 here. And then 4, 6, 7, 9, the determinant of the remaining elements. And the last one will also be a plus from this one. And then, oh yeah, I forgot to cross out, it's this column. Then the 3, which is the element from here. And then the determinant of the remainder, 4, 5, 7, 8. So this is the example. Now we know how to compute this because we've already talked about 2 by 2 determinants by just taking the diagonals and subtracting. So if we did this, we'll get 1 times, this is 45 minus 48 is minus 3, minus twice 36 minus 42 is minus 6, plus 3 times 32 minus 35 is minus 3. So what I get basically, this one is plus, it's 12 minus 3 minus 9. It turns out to be 0. So that's the numerical answer. And now I'm going to introduce another concept, another word, the minor of an element. Let's take this last computation we did, the 3. The 3 is element in row 1, column 3. I mean, let's suppose that the elements of this matrix, the 3 by 3, are A, I, J. So this would be the element A1, 3. And this determinant is called the minor associated with this element, the 3 together with its minor. And the minor is labeled big M and then also 1, 3. And in general, M will have 2 indices for each I and J. Let's show the other examples we did. This element in row 1, column 2, the 2 here, its associated minor is this determinant, which we call M1, 2. We also know what it's equal to. It's equal to minus 6. M1, 3 is equal to negative 3. And the determinant that we got for the first one, it's this determinant, and this is M1, 1.